So let us discuss the first decision point, whether to remove or basically drop a row, okay, a row or not. Okay, now this is very important, drop a row or a column, for example. So if you talk to me, that I will say that there is no standard rule in market right now that okay, if these many certain rules are so like there is no hard and fast rule that if these many rows are missing, then it means you will remove the data set, some those kind of things. But let's try to build on a business logic. Okay, and I will try to share my experience, like what I have seen in my career. So I have built a general formula for myself, but again I'm saying it is not a universal formula. You still need to evaluate each case separately. Okay, so if I talk about, let's say, now what is the issue with dropping a row? For example, let's say there is a table, right? If you remove lot of rows, for example, if you see okay, one information is missing, I remove the whole row. Now if you remove lot of rows, then there is a loss of information, correct? There's a loss of information. If you don't remove the row, if you don't remove and there are a lot of missing value, for example, then there is a inaccuracy in data, right? So these are the 2 points like which are opposing each other. Now you have to find a common playground between these two, that you can remove as well and you cannot remove as well, totally depend upon the thing. So a general practice that I have seen, for example, if your data, if less than 5% data is missing, okay, 5% data is missing, then you can drop it. Then you can drop those rows. Okay, 5% of rows technically. So means less than, for example, out of 1,000, let's say you have only 50 rows which are missing. Sorry, right? 50 or let's say 40 rows which have missing values. Then you can consider dropping those rows. Okay, but again the main thing come. For example, let's say there is a row with 30 columns. Okay, let's say there is a row with 30 columns and it has only one variable missing. Okay, will you remove it there also? So you will not, right? So the second rule that comes here is which I generally follow, that if you have greater than 20 to 30% of the column missing for a variable, right, then only remove them. Then only remove them. Okay, so there are two conditions. If less than 5% data is missing, then remove, and if greater than 20 to 30% of the column is missing, then only remove. So let me explain this concept once again, if it might be confusing if you are hearing for the first time. So what you do is that you have a data set, right? Now there can be, if let's say our data has 1,000 rows, for example, in this case. Now if you see that you only have less than 50 rows missing, 50, you have only, for example, for any column or anything, you see only less than 50 rows missing, then you can consider dropping that entire row. Okay, but again, this is not the only condition. The second criteria that you need to identify match is if for that particular row on more than 20 to 30% column are missing, right? So let's say you decided to drop row number 562 because it had one row. You saw that there is one null value in there, but you evaluated row number 562. You see that out of 30, 29 variables have the missing value. They have the value. Okay, and there is only one variable with missing value. So will you remove it, 562? No, you will not remove it. So these two rules you need to keep in mind parallelly, that again repeating, if less than 5% data is missing, then you can consider dropping. But before dropping, visualize that there should be at least 20% of the information missing in that particular column, in that particular row. Okay, if you do that, then you can consider dropping any particular row. Same thing applies for a column. If for a column you see that, for example, if for a column you see that greater than 40% of the information is missing, then you drop it, otherwise you don't drop it. Okay, that's what my experience says. So I will summarize here. So summary says that first says less than 5% data missing. Okay, then drop it, along with second condition that greater than 20 to 30% column missing. This is your first criteria. Okay, column missing. And fourth, if you have to remove a column or not, that depends totally. General practice that I do, if greater than 40% of the rows are missing, okay, then only consider removing a column. Otherwise, don't remove a particular column. So this is the condition to remove a column. This is the condition to remove a row. Again, I am saying this is no scientific based information. This is entirely based on my experience, on whatever research papers I have read, or whatever like projects I have done. This is based on that. These thresholds you can vary like little bit, but this is a general blueprint that I'm giving to you. That is there any decision boundary to drop a row or column? Yes, you can create. Okay, but there is nothing universal right now that okay, we have to go with, like sometimes you have to be business oriented as well. That totally depends upon yourself. For example, let us say in our particular scenario, right, we had these particular rows. For example, we had 1000 rows. If I try to visualize this, right, this is 132. It means, for example, budget is 132, so it means 13%. This is 12.4%. Is there any row which is less than 5%? No, there's no row which is less than 5%. So there is no point in removing any of the row from my data set right now, because we will have to impute these values or maybe make some other decision. So that is the reason we are not dropping any of the row. But let us say we had to drop, or let's say we have to drop any particular thing. So how to do that? For example, right, I will try to give a framework for that. One more thing, before I create that code, I forgot to tell that, for example, we were talking about, right, that there should be at least 20 to 30% column missing. All right. Okay, now if you see that we had 30 columns, okay, now we have 1 2 3 4 5 6 7 8 9 10 11 12. We have total 12 column missing, which have missing values, and out of which 30, so 12 divided by 30 technically is, so roughly 30, like approximately 40% of the data is of columns which have missing values in some of the rows. So you will need to analyze each row specifically. But again, if overall I see that my data is like more than 5% missing, right, then I cannot drop rows directly. That is the key here. So now we will move. Let's say if you wanted to remove any specific row or column, how will you do that? Let's say in our case we are not doing, but I'll show you how to drop drop any particular column. So what you do that, for example, let's say we had this data frame, right? So you will create df2, let's say df clean. Okay, how will you do remove any particular? You will just do df dot drop. Okay, and let's say you just need to provide columns equal to, just provide a list of column names, whatever you want to keep. For example, let's say I see that OTT release has a lot of missing values, right? So if we can simply go OTT release, okay, and we just close it. Okay, and now we just print, or we simply do df underscore clean, okay, and dot head, okay, and let's simply run it. So see, 29 columns are there, okay, because we have removed the second last one. Before, if you see critic score, remarks, and there is SQL, so OTT release is dropped. If you want to drop any particular any column, right? So I'm just saying that if in case if you require in future to drop any particular thing, so that is how you can approach. Now there is another method, like let's say if you want to drop a particular row, how you can do that. So to drop a particular row, you simply do one thing. Let's say 2, for example, df.drop, everything remains same. Instead of column, you need to provide the row index. So you will say index is equal to, okay, and let's say whatever index you want to provide. For example, I want to remove row number 0, or let's say row number 3. So you will use that, okay, and simply just run this. So let's see which is our index 2. It is Sholay, right? The movie name was Sholay. So we'll try to remove this. Let's see if it goes clean. So Sholay should not come here. right? If you see, 𝐶𝐲𝐬 is not PK Mughal-e-Azam, and then 𝐶𝐲𝐬 is dropped from this particular method. So that's how you can drop either a row or a column depending upon the use case. But as I mentioned, try to keep this particular scenario in your mind before dropping any row or column. There are better methods than simply removing. So that's the point, because in most of the time your manager or something, they will not let you delete the rows. They will say find some ways to figure it out, right? They will not let you do that directly. So that is the point. But yeah, that's about dropping a row and a column. Now we will move towards imputing values. So we are going to talk about imputation, right? So first method we discussed about dropping the rows. Now we discussed about imputing. Imputing means filling your missing values with some information. Okay, imputation means that. Imputing value. Now for imputation, there are multiple strategies. Okay, so there you can actually impute based on some statistical measures like basic, mean, and mode. Okay, you have mean, mode, and median, three basic statistical measures. Then there is regression. Okay, then there is interpolation. Okay, then there are few miscellaneous techniques which I will speak about. Okay, so there are multiple things, but the most intuitive that comes to our mind is putting replacing them with mean, median, and mode. But it's not that easy that you can replace anything with just mean, median, mode, and there is a proper strategy to each of that, and we will be discussing that, like which particular part means what. So first of all, to impute value, you need to check, for example, whatever your missing columns are, right? You need to decide whether it's for example, let's say you have the missing columns. Okay, now you need to decide whether that is a numerical variable or if it is a numerical variable or it is a categorical variable. Okay, we will speak about each of these separately. So now please try to just take a screenshot of this video here so that you have all these sorted, because I will have to refresh the page. So to talk about the missing value, right? So as I mentioned, let me refresh the page. So numerator and numerical or categorical, right? So what is a numerical variable? Numerical is anything. For example, if I check in our case, it is budget. Okay, budget, and it could be a collection, that is money. And what can be a categorical variable? For example, if a movie is sequel or not. Okay, date. These kind of variables are categorical. So we will talk about, first of all, we'll talk about numerical variable. So the thing about numerical is that there are multiple strategies. They can be filled with all of the mean, median, and mode. They can be filled with mean, median, and mode. Okay, mean, median, and mode. So let's take an example first of all, a rough example here only. Let us say we have a data set, for example, 5 values, 1, 2, 3, 4, 5. Okay, the first value is, for example, 150. Second value is 180. Okay, third value is for example, let us say it comes out to be 160. Okay, the fourth value is 130. Okay, so now if I ask you, tell me what, let's say fifth value is missing. So here, can we do a mean? Yes, we can do a mean, because thing is that all these values are very nearby. There is no outlier. Remember, you have to impute mean when there is no outlier involved. Because for example, let's say there was a value known as 1130 here. If you take a mean of that, then by default your mean will average of all this group will automatically rise, right? And you might put somewhere value around 600. Now this can be an outlier, and this outlier will affect it, right? So you have to ensure that your data does not has any outlier if you want to impute with a mean. And the second thing which is very important, that it has to be a normal distribution. Okay, the data does not has to be asymmetric. Now what do I mean by a normal distribution? Is basically data should be following this particular path of values. So 95 percentile here, then 67 percentile here. Okay, now for outlier, we know we do a box plot. We discuss that we do a box plot test. Okay, But for normal, how do we, like, we lot of time you would have heard, okay, the data should not be normal, but how do I analyze whether my data is normal or not? Okay, so how to do that particular thing, to whether check whether my data is normal or not? There are two figures that we will need to draw. One of them we have covered, that is histogram. Another one is little additional QQ plot. Okay, so don't worry about them. I'll just explain. So to check, first is histogram. You'll use the KDE method, which I explained in the matplotlib and C1 class. And second is a QQ plot. I didn't explain this particular part. You just follow what I'm doing, right? I will try to explain it more detailed during that video, but just follow that what I'm doing. Okay. So we will be creating these two charts to check if my data has only my variable has any outlier or not. So first of all, I'm checking whether I can impute my variable with a mean or not. Okay, once we do that, then we'll build strategies for median and mode as well. So let us go to our data set, for example. Okay, so what do we need to do is we need to create an histogram, right? So first of all, I will be creating so let me import the libraries once again. Let's say import so okay, import pandas as PD. Okay, import 𝐶born as SNS, import matplotlib.pyplot as PLT. I'm just ensuring if I have my library. So import numpy is not required. There's a new library I didn't cover. It's a very basic library. We don't need it much of the cases, but for advanced charts, sometimes we use that. There is scipy.stats. Okay, we don't need to cover as stats. It is used to get the QQ plot, right? I will explain them that why is it required. So first of all, let's create a histogram. Okay, now let's say first define, we want histogram across which value. So for example, let's say I want histogram for budget. Okay, we have a lot of missing value. We can test each of them one by one. Here in this video, because of the time limit, I will just explain using one variable. Then you can analyze on multiple variables on your own. Okay, so how to do that? For example, let's create a so yeah, we will do SNS dot hist plot. Okay, and what we need to do, the data set that we need to df. So just let me run the df as well once again, because I don't know how many times did I change it during the process. So just let me run the df as well once again. Okay, right, so df, and which column do I want, that I need to enter. So let's say I want for budget. For budget, I want to check how my distribution looks like for budget, like is it normally distributed without, after removing duplicates, right? Because I just want to check if I have to impute values to it, are my other values normally distributed or not, right? So that is why I will remove the and missing values from this particular column. Okay, and what I will be doing, I'll be doing KDE equal to true. So KDE equal to true. This is something we did in the histogram class as well, in the 𝐶born class. Okay, now once we do that, let's check what comes. So if you see this particular chart, the data is following us. It's not perfectly normal, but it is not skewed. It is neither to the right nor to the left. So it is fine with me, right? I mean, I can say that it is following a similar path. So it is following something like this. So I can say that it is not something that is skewed. Okay. Now I can do one more thing. There is also a chart called QQ plot, right? So how do we do that? For example, we simply go to stats. Okay, the stats library that I generated from here, this one, scipy. Okay, we'll go to this. There's a probability plot. So just remember this method, how to get. You will not be using this chart excessively, but I'm just telling for those who are very inquisitive, they want to know how to check whether a variable is normal or normal distribution or not. So you do probability plot. Okay, after this, what you need to provide the same thing, the variable name. So which we just provided here, df.budget. Okay, drop in. This is my column. Okay, and this will be my drop NA, and I want a normal distribution. Okay, distribution is equal to normal, and then I will do a plot. Okay, plot is equal to, I'll use matplotlib to get this. Okay, so this is how it is done. Don't worry if you're seeing for the first time, it's totally fine. Just try to understand the inference that I will try to derive from this. Okay, so this is I got. Now what I need to do, plt dot show. Okay, so if you see, this is a chart. What it says, remember, we will cover this chart. It's not necessary for you to know, just remember this thing. If your this line is diagonally straight line, it means your data is normal distribution. Okay, this is something you should know. These are basically percentile. So 0 means 50th percentile. This -3 means 1.1 percentile. So the data is distributed in these intervals. Okay, this is the central interval, and this is all that. So if your line is following a straight line, it means your column is normally distributed. Let's try with some other variable. For example, let us say go with something weekend gross. Okay, weekend gross. Let's try to check that. Weekend gross. Okay, this is also normally distributed. So as I mentioned, most of the data I've checked this, it is normally distributed in this data set. So you can actually do a mean thing here. Now, next thing you want to check is outlier. Okay, so to how to check the outlier, if you remember, there is a box plot method. So how you can get the box plot method is simply you use SNS. Okay, if you remember, box plot, and then you need to simply do x is equal to df and your column name, for example, budget. Okay, and you need to just simply pass this, and that's it. I think it will give the chart. Yeah, if you see, there's no you don't see any I'll say you don't see any outlier present in this data set. Otherwise that would have been marked here. Okay, so this shows that our data set is it is normally distributed. It does not have any outlier. So we can use mean. For example, for budget, we can use mean to impute values, right? So we can simply take a method and impute all the missing values by mean. So now we'll try to write down a code so that we can impute. For example, we just saw that budget is normally distributed, right? So we can remember, we can use other median and mode as well. But if your data has no outlier and it is normally distributed, go with mean. Okay, so what you do, we'll try to change all the values in my table. For budget, I'll replace it with mean value. So how to do that? For example, this is my df. Okay, so how to do that? Df, you will simply use budget, that is your column name which you want to impute. Okay, so df budget. Okay, now how we want to fill this value, so we'll use fill na. Okay, it means that we are filling missing values. Okay, and so with what we are doing, it should be df. Again, you'll enter the budget. Okay, and so you are replacing it with mean. So you'll use dot mean method. So it means that you are replacing this column with this column dot mean, right? It means you are replacing this column with a mean value. And now there is a method called as in place. So what does in place say? In place hyperparameter says if you directly want to make changes in your main data set, then you use in place equal to true. But if you just want to create a new data set, then you choose in place is equal to false. So it's up to you, right? This is how you do it. So once you perform this activity, just a second, unmatched. Okay, I think it will run now. the behavior will change. Okay, so there is some issue with the version, so we'll have to use some this but the method that they have told, right? That try using df dot method this particular, right? Or this instead to perform an operation. So let's do one thing. We'll create a new object. So we'll rather change in my main data set only. We'll do df dot fill na, okay, which they just said, and we are going to use for example this. Now we have to use a dictionary, that's what they are saying. So call, let's say column underscore name is my df, and let's say budget, okay, dot mean, okay, and I am replacing it with this one, and I'll close the key. Let's run this, and now let's print df. So now to check whether it is missing or not, what I will do, I will simply go and check my first method where I had info to check again df dot info, right? I'll just check if my budget column is missing now or not. So let's run this. So if I go to budget, see 1000 values are non-null, okay. We see that my budget has been imputed with these particular values. So that's how we will do this. Now similar, let's say let's create that this particular graph as well, which we created. So let me copy this directly from here, and we'll see our budget column, how things are there. So if you see, budget has no this yellow line now. So budget has been totally imputed with all the missing values. So that's how we did the imputation for the budget in this data set. And similarly, you can use similar method to impute box office as well. Like all the numerical variables you can use. Remember numerical continuous variable, not the categorical. For example, the box office is numerical, duration is your numerical, rating is your categorical, votes again is numerical, then your weekend gross is numerical, total screens you can say it's numerical, awards won is numerical, sequel is categorical, OTT release is categorical, remake is categorical, critic score is again I will say it's a numerical score, right? So depending upon the like which type of variable it is, you can impute it. So now we will discuss the other methods as well, when to use mode and median as well. So in like few seconds back, we just saw that how can we use mean to impute values, and as we mentioned, the mean can be used when your data is normally distributed, okay, and you don't have outliers, okay. But this is not always the condition, because your data might have outliers. So for this comes mode. Now we will try to visualize mode. Median, not mode. I will speak about mode as well, but next thing comes is median. So why do we use median, for example? So let's take an example. Let us say there is a class, okay. There's a class which has five students, and the average the student 1, 2, 3, 4, 5. There are 5 students in a class, okay. Now let us say and sixth, for example, let's say 6 student is also there. So for example, let's say you want this student has marks 12, this student has marks 12, this has for example 15, okay. And for example, this student let's say it has 17, and this student has marks 98, okay. Now you want to fill in the value of the marks for student number 6, okay. That is the point here. Now there are two techniques, like so far what did we see, how to impute missing value? We simply use mean, right? So let's say someone asks you, tell me the average marks of the class, okay. What is the average mark of the class? So what you will do, you'll do 10 plus 12 plus 15 plus 17 plus 98. Okay, and you will divide it by 5. So you will get 30.4. This is the average mark of the class. Okay, now if you say that okay, the average mark, so you say that okay, because the average mark of the 5 student was 30.4, so I'll impute this as 30. But hold on, is this correct? What if I remove this particular 98? Because this 98 seems to be way higher, because 12 plus 15 plus 17. Okay, and we divide it by 4. So what do we get? We get 13.5. So average is 13.5. So see, now this is the difference, right? You impute 30 or you impute 13.5. That is the main point here, which we should know, because I mean, it's they're very different, right? It's telling that average mark of a class is 30 or 13.5 means a lot. Okay, so here when you, just because of this outlier, just because of one value, your average marks of the class has shooten up a lot. Okay, so you cannot technically say that okay, this is something that the real depiction of the class. And there comes the next pointer, that is called median. So what does median say? That median say that first of all, if you have to impute something, what you should do is take the so you have to take the cross all the values in an ascending order. So for example, in the ascending order, these value will become 10, 12, 15, 17 and 98. Okay, so you put them in ascending order. Okay, now what does the median, if you know median, right? Median says pick the middle value in this list. Okay, so the middle value in this list is 15. So you say that the median of this particular list is 15. Okay, and now what you do, you impute the missing value. Instead of 30, you impute it as 15. Now tell me, which is more closer to 13.5? Is 30 more closer or 15 more closer? It is actually 15 which is more closer, and just by using median, we are not letting this outlier affect our overall the main information that I want to get to know about class, right? So in these examples, whenever you have outliers present, you will be using medians, not mean, right? So that is the concept here. So this I just explained using a simple explanation. Now in our given data set, we don't have any outlier, but still I will try to show you, if you want to impute, basically if you want to change anything to median, how you can do that. So let us go imputing the median value, right? So what we will do simply is that we will do median. So what is the median? So for example, we saw that our budget got sorted, right? But we have other variables as well. So we'll just try to fill in median value. Let's say for box office. Okay, we just want to fill it with the median value. So what we will do here is that we'll define a median which is equal to df. Okay, and the variable name is box office. Okay, so we will do this dot median. Okay, we have defined this variable. Now what we are going to do, simply we are going to a data frame df, and which is my variable name is box office. Okay, and dot I'll fill NA, okay, with median. Okay, and in place I'll put equal to true. Okay, and so yeah, I think this should do it. Okay, I mean that we need to change our method as well once again. So let's do one thing. The way we imputed the value in for example this one. Okay, so we will just impute it like median only. So what we are going to do, in the previous step we took df is dot fill NA, the column name is box office. Okay, so we'll do box office, and we'll do box office, and we will paste it here, and it will be median. Okay, and now if we fill this, right, so we have got all the values. So now let's do one thing. Let's check df dot info. Okay, now let's print this. So we will see that for box office also we have got all the values processed, right? And I will just simply print out this particular chart that I create, the heat map that we created for box office. So let me just paste it here, and what is my variable name? So df is null. Yeah, so I just simply run this. Now if you see, our box office is also sorted. So this is how you will impute median. So the key thing is that you should remember, when you have to impute mean, when there is no, it is normally distributed and there is no outlier. When you need to use median, when there is outlier. Okay, this is something you will use then. Now we will speak about the third statistic measure, that is mode, and how to use that. So now we move ahead with the discussion about, so again, as I mentioned, we discussed about mean and we discussed about median. Okay, remember these two are used for numerical or categorical variable, numerical or continuous. Okay, numerical, continuous. So what do you mean by continuous variable? For example, sales, right? Sales is something like 200, 200.2, right? The numbers can take any number. Okay, they don't have any stop point, they can go up to any number. Then there comes a second type of variables which are categorical or discrete. Okay, so in categorical or discrete there can be multiple two type of values. So they can be simply character values, okay, or they can be numerical as well, depending upon the case. Okay, so they can be numerical as well. So what do I mean by numerical? For example, customer segment. Now you can say customer segment, or you is 1 2 3 4 5, right? This is not a continuous variable. Like customer can only have one of these segments. So this is kind of categorical variable only. Or again, another categorical value in characters is, let's say, low income, medium income, high income. Okay, so these are called categorical orders. So for imputation for these particular, like if the missing column is either a categorical, then there is a different strategy to impute values, right? So we will discuss about those particular characters here. So let's discuss about those methods, and once we do those methods, after that we will go towards solving, like filling few of the variables using these methods. Okay, so the first is for example, what you can do is mode imputation. So what do you mean by mode imputation? Is, let us say there is a variable called so gender. Okay, in gender, let's say you have 5 rows. So let's say you have 1 2 3 4 5. Okay, gender is male, 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 female, female. Okay, now suppose you have to this column, row number 6 is missing for this column. So how will you impute it? You will see that, okay, which of the, so gender has two categories, two variables, right? It either is male and it either is female. Male is appearing 3 times, female is appearing 2 times. So what is mode? Mode is that particular value that is appearing most of the times. So here, because male is appearing most of the time, you will replace it by male. Okay, because it is the mode of the data. Okay, so this is technically called mode imputation. There is another thing called method known as constant value. You can impute with a constant value as well, just to say that, okay, this is not missing. So you can just replace it by using, you can create a new category, NA. Okay, so instead of saying blank 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 missing, you can say this is NA. Okay, so you can replace it by this method as well. The third method that is used to impute categorical is similarity or grouping. Okay, so what you do here, for example, let us say you have multiple missing values. For example, let's say you had in this case you had 6 missing and you had 7, row number 7 also is missing. Okay, so so let me just erase this one. Let me just erase this one. Okay, so let us assume this was my variable. Yeah, so let's say this was my variable gender. Okay, now gender had below column, so it had male, male, female. Okay, fourth is again female, fifth is male, sixth is male. Okay, now you have 7 and 8 missing. Okay, so what happens is that you see that if you see the distribution, male is 3 times, female is also 3 times. Or let us say you can say that, for example, the ratio. So you see in here male and female are in the ratio of 50 to 50%. So you see that, okay, I have to impute two values and I want to maintain the ratio between male and female. It has to remain 50-50. It could be 60-40 as well initially, like whatever it was, you just want to maintain that particular ratio. So here what you will do, you'll impute one with male, one with female. Okay, that is something you can do. Let's say, for example, there initially there was something like for example, we had 6, right? So we can do, for example, initially we had male. Okay, then we had male, and then we had female. Okay, then male, then female. Okay, so what, now let us say you have next thing as male. Now you want to impute this thing. So what you will check, the ratio of male to female, and just to ensure that it aligns with this one, you will fill in the value here. So here female will come or male will come, whatever according to that. So this is based on ratio. You just want to ensure that the ratio between the categorical variables remain same. This is any value. Okay, and a mode imputation, you use as I mentioned, the one with the maximum value. So this is how you do. And the fourth method that is very useful is predictive modeling. Okay, so here what you do, you use classification models to predict values. So we will not be covering this right now because this comes under machine learning. But what we do, for example, we create a simple random forest. Okay, you create a random forest distribution and you can predict, okay, what can be the missing value using them. You random forest, or you can say a decision tree. Okay, or you can, like, whole machine learning is this only, that predicting a particular missing value. So you can use a machine learning technique as well. But these are the major techniques through which you can impute mode to your data. So let us say I want to impute a mode value for my categorical variable. Now let's see, there are a lot of categorical variables present in my data. So if I check the distribution, I see there is a variable awards one, sequel, remake, OTT release. All these are categorical variable. So let us say if I want to replace anything with the mode. So for numerical values we already did, right? Budget, office, budget we did. Now I want to use a mode on remake, for example. So what I will be doing is that, again, I have to follow the same concept like I did above. So I'll first of all create a mode value. For example, mode, let's say mode underscore value. Let this be equal to, so df. Now what is my variable name? Remake. Okay, and I want to convert it into mode. Okay, and remember, once we convert it into mode, to get the mode value, it basically converts into tuple, right? That this is the value and this is the frequency. And so if to get the value, we need to convert to get the first because it gets converted to a tuple. For example, let's say I do this. Okay, now if I do print mode underscore value, what do I get? Okay, I get a yes, variable name, remake, and data type object, right? So to get my value, right? So what I need to do, I need to pass it and use the 0 here to get my first value. Okay, so that is remake. What is my mode value exactly? So now after this, what I will do, I'll pass this information into df is equal to, we'll say df dot fill na. Okay, And how to fill that? Remember, we have to use a dictionary. So what is my dictionary looking like? I'll say remake, okay, and to remake, and what do I have to replace it with? Mode value. Okay, so I'll replace it with a mode value, and I think, yeah, that is done. Now once I run it, closing parenthesis, okay. So now if I print, if I do df.info, let me check. So if I check my remake, now it is 1000 non-null. So see, my value has been filled. Right here my remake had 662 non-null. Now I have filled it with my mode value. So this is how you can impute the values with mode. So this was the basic imputation method, right? We just discussed all the major methods that we use. So let me create a rough blueprint once again so that you can save a screenshot and keep in mind, right? So a variable can be of multiple types. Okay, now a variable can be a simple continuous numerical variable, or it can be a discrete. Okay, it can be a discrete, and inside discrete it can be either a character variable or it can be a numerical variable, right? So what are the methods to impute here? So I'm really sorry for my poor handwriting. The first method is you can do using mean, but what is the condition for mean? There should be a normal distribution and there should be no outlier. Okay, no outlier. If there is an outlier, what you use median. Okay, this is the first approach. Now in this case, what you do, you first of all replace it by mode. If you don't want, you can replace it by a single constant value, or you can replace it by again based on your mode only, your distribution, that to maintain the distribution ratio. And the fourth is predictive model. Okay, these are the major methods you can do. So we did using mode. These two are similar steps only like mode. So so now this is the general architecture. Now again saying there are some additional methods as well to impute the values, because sometimes things are not that easy. There are better imputation methods for few of the cases. So like forward imputation, backward imputation, right? And there are few others. So we will speak about them like in few minutes from now.